Hi, and welcome back to another lesson in this series with me, Sally. This is the third one so far. In the last lesson, I showed you how to create your own data sets using the intuitive functionality of the graphical join tool. I did this by creating the accounts payable container for the receivables and payables dashboard that I designed for my business. I've shown the final design on screen again to remind you what it is we're working towards. In this lesson, I'm going to take things to the next level and show you how to create containers using SQL. If you're not sure what SQL is, then don't worry, as I'll share some details on it shortly. And I'll teach you how it can be used in the connector as I create the accounts receivable data set for my dashboard. This will introduce you to two of the other types of containers you can make use of in the connector: the SQL join type and SQL query type. Before getting into it, I want to point out that I don't have to use a SQL join type container or SQL query type container along with SQL to create the data set for my accounts receivable. The structure of my accounts receivable data set is identical to my accounts payable one, except that it uses different tables. The easiest way to implement it would be to follow the example in lesson 2 using a graphical join type container. And you may feel more comfortable only using graphical joins for your data sets going forward. I am, however, doing things this way to share some of the other common functionality in the connector. That being said, much of the content in this lesson is intended for a more advanced user or someone who is wanting to learn more about SQL and how it can be used in the connector. Even if you aren't intent on using this additional functionality or getting into SQL, I suggest you follow along even at a high level, as it will give you a greater understanding of containers. You'll see the differences between the different types, which will make some of the comparisons that I make in the upcoming lessons clearer, and it will help you in making amendments to your out-of-the-box data sets if you ever need to. With that in mind, let's get started with some SQL basics. SQL, or SQL, stands for Structured Query Language and is a standard language used for querying and manipulating relational databases. Although it provides the ability to create, edit, and delete tables, the connector restricts you from this, only supporting those functions that let you query the data in your database. The most basic form of a SQL statement begins with the select keyword, followed by an asterisk, then the from keyword, followed by the name of a table you want to view. The use of an asterisk means that all fields from the table will be returned. You could then replace the asterisk with individual field names separated by commas to return only those fields. Seeing as I'm going to be working with some of my accounts receivable tables in this lesson, I'm going to share some examples using them. The statement select asterisk from AR_customer will return my entire accounts receivable customer table. And the statement select customer name, city, state from AR_customer will return only the customer name, city, and state fields from the same table. This example could be used to tell me what city and state each of my customers are located in. As we saw in the last lesson, the power of SQL lies in its ability to combine data from multiple tables, and this can be done by joining one or more tables together. The syntax is placed after the from keyword in a select statement. When joining tables, the 4 different join types can be used, which, if you recall, are inner join, left join, right join, and full outer join. Their keywords are as they are pronounced. When joining tables, you also have to specify the primary key and foreign key that you're joining them on. This is done using the on keyword, which follows the join portion of a select statement. Now, because you are referring to fields in different tables, which may have the same name, it's important to specify which table a field belongs to so that there is no ambiguity between them. This is done by prefixing a field name with its table name, and it's also a good idea to do this to the fields you are selecting. In the following example, my accounts receivable customer and invoice history header tables are joined together using an inner join on the customer number primary key field in the customer table and customer number foreign key field in the invoice history header table. The customer name field from the customer table is returned, and the invoice number field from the invoice history header table is returned. I could use this to show the invoices that belong to each of my customers. Another feature of the connector is that it provides an easy way for you to experiment with SQL. This is through the Direct Query tool, which can be found on the Tools tab on the menu ribbon. By clicking it, you're first asked to select the connection you'd like to use, implying the database you want to query. And after clicking OK, the tool is opened in a new window. You can now enter a SQL statement in the pane at the top of the window and then execute it, either by selecting Query and then Execute from the menu, or by pressing F5 on your keyboard. The results are then shown in the bottom of the page. This is a great way to test SQL code or investigate the data in your database tables before creating containers. I'm now going to take what I've shown about SQL and apply it in the connector to create my accounts receivable data set. We're already most of the way there. The first thing I want to do is take a look at my accounts payable container again. You can see under the Join SQL field that a full SQL statement hasn't been used. It's only the join portion of the statement. This is because in the case of a graphical join, Sage Intelligence adds the select portion when the query is executed during a report run, with the fields included being all those you have added to the report in the Report Manager. This is the same for the next type of container I'm going to work with, which is the SQL join. I'm going to go ahead and add it. To remind you how to do this, select the connection you want to use and then on the Home tab, click Add Data Container. You can then choose the type. I'm going to pick the second option and click OK. I can then enter a name for it, and I'm going to call it Accounts Receivable. After clicking OK, it's added to the connection. If I select it, you can see there is now a source container field under the properties where I can enter the SQL for it. Remember, though, that this is just the join portion and not the full select statement. Although you can edit the field directly, you can also access an editor for it by clicking the ellipsis to the right. This may be easier to work with and also allows you to execute the statement so you can test it. I've copied the join portion of the SQL example I shared earlier that included my accounts receivable customer and invoice history header tables to my clipboard, and I'm going to paste it into the editor by selecting anywhere on the top pane and pressing Ctrl-V on my keyboard. Similar to my accounts payable data set, I also want to include my accounts receivable invoice history detail table in the join. All I have to do is add the join at the end of the existing statement, and I'm going to type in the information. This is inner join AR underscore invoice history detail on AR underscore invoice history header dot invoice number equal to AR underscore invoice history detail dot invoice number. Once finished, I can test the join to make sure everything checks out. I can then click OK to update the source container field, as well as Apply on the Properties page to save the changes. My container source definition is now complete, and the next step, which you may have guessed, is to add the expressions to it. Remember, to do this, select the container in the Object window and click on Add Expressions on the Home tab. Select Data Fields, then the tables you want to add expressions from, and then the expressions you want. I'm going to include all of mine again. It's possible for some columns and tables to be the same or just have the same name as we've seen, and there's something to take note of here. If such columns exist and you add them to a container, then it may appear as if you have duplicate expressions. It may then be difficult to know the right field to add to a report in the Report Manager. In the connector, you can distinguish between columns with the same name by looking at the expression source field under their properties. As an example, I have two comment fields, and by looking at their properties, I can see that one is from my invoice history header table, and one is from my customer table. These fields are different, and if I wanted to use one in a report, then I would need to know the right one to choose. If I was certain I wasn't going to use the other, then one way around this would be to delete it. And I can do this by selecting it, clicking Delete on the Home tab, and then confirming the action. If I wanted to keep both fields, then the other option is to change the name of each one, for example, by appending the table name to their titles. The expression name is the name that will appear for a field in the Report Manager, and I would now be able to identify them appropriately. For the sake of convenience, I've gone ahead and updated the fields in both my containers, removing any that aren't essential to my data sets and changing the names of similar ones I want to keep. I'm now ready to create reports from them, and I'm going to go ahead and do this to highlight some details about them. In the last series, I showed how to add a new report, so I'm going to run through the steps of adding the one for my first container quickly. After selecting the folder and clicking Add Report, I'm given the choice to add a standard report or union report. I'm going to select Standard and click OK. To give you a heads up, once I've created the two individual reports, I can combine them together using a union report. I'll get to this in the last lesson. I'm then asked to give the report a name, and I'm going to call it Accounts Payable. After clicking OK, I'm shown the list of available containers, and you can see that the two I've created are there. I'm going to select the first one and click OK. I'm then given the list of expressions that I added to the container. Since I've already refined these for my needs, I'm going to select all of them. The report is then added to the folder. Rather than running through this again for my second report, I'm going to jump ahead to where it's been added. In the last series, I discussed the different tabs that are available for a report in the Report Manager, and I mentioned that those available will depend on the type of container that it makes use of. What I want to point out is that for both my reports, all the tabs are shown, and this will be the case whenever a graphical join or SQL join type container is used. What this means is that if you want to work with the Filters, Sort Fields, and Aggregate Filters tabs in the Report Manager, then your containers will need to be based on a graphical join or a SQL join. I'm now going to move on to a container where this isn't the case. This is the SQL query type container. It makes use of complete SQL statements and provides the most flexibility when working with SQL code. Because of this added freedom, the Filters, Sort Fields, and Aggregate Filters tabs are not included in the Report Manager, and the intention is that if you want to make use of functions like these, that you implement them in the SQL code. Instead of adding a new container from scratch, I'm going to convert my accounts receivable one to a SQL query type. Although there are situations where you may want to do this, they aren't very common, and it's generally easier and advisable to create a new container from scratch. Running through this example, however, will help illustrate the differences between a SQL join type container and a SQL query type container. Rather than just switching back to the connector, I'm going to show you a convenient way to access a reports container from the Report Manager. By double-clicking on a report, take note that it has to be unlocked first. A number of options are shown below it, most of them relating to the available tabs for the report. There is an item there, though, named Source Container, and by clicking it, the name of the report's container is shown. By right-clicking on the name, you're given the option Go to Container in the connector. And by selecting it, a new instance of the connector is opened with the container highlighted, ready for you to work with. This is useful if you're in the Report Manager and don't have the connector open to begin with, or you have a long list of containers making it difficult to identify the particular one to change. Now to convert my container, I first need to change the type, and I'm going to select SQL Query and then click Apply. I now need to update the SQL code in the Source Container field to be a complete SQL statement. This requires that I add the select and from keywords at the start of it. For the fields, I could use the asterisk to include all of those from my join, but I'm rather going to define the specific ones I want explicitly in the code. I've gone ahead and entered all of the ones that I added as expressions to my joint type container. The source for my container is now complete, and I'm going to apply the changes. Now for the expressions. If you have converted a container, it's best to remove the existing ones and add them again. This also means removing the columns in the report manager, which would have to be done anyway because you can't delete an expression, or a container for that matter, if it's being used by a report. I've gone ahead and done this for my accounts receivable report, and I've also gone ahead and removed the existing expressions from my container. Now, when I go to add expressions to the container, you can see I'm not asked to select the tables I want to choose columns from, but I'm just given the list of columns I defined in my query. I'm going to select all of them and click OK. If I then display the properties of one of them, you'll notice the format under the expression source field is different to that of the previous expressions, or those in my accounts payable container. Because the new columns are defined explicitly in my query, the source field doesn't need to be defined explicitly again in each expression. And so instead of having the table name and field name, only the field name is needed. The changes to convert my SQL join type container to a SQL query type container are complete. As I mentioned earlier, it's unlikely that you'll ever need to do this, but in the event that you do, you now know how to go about it. There may also be instances where it's useful to convert from a query type container to a join type, and a similar process would be followed. What's more important, though, is that these changes help to highlight the differences between a join type container and a query type container, and show the requirement and the ability you have to use full SQL statements to define the data you want for your reports when a SQL query container is used. I could take this further by making use of other SQL clauses in my query, like the where clause to filter records, the group by and having clauses to perform aggregations, and the order by clause to sort fields, as well as make use of more complex SQL functions. I'll touch on some of these in the next lesson. While I have the properties of my container open, there's another point I want to mention. By clicking the Show Advanced checkbox at the bottom of the window, the advanced properties for the container are shown. One of them is Execute with Universal Query Engine. If you are a Sage 100 user connecting to a Providex database and you create a container that makes use of more advanced SQL functions, then you may need to check this. This is because the database driver for Providex only supports limited SQL functionality. By checking this option, you can define a container using a wide range of SQL functions, and the Universal Query Engine, or UQE, will convert the query into code that Providex can accept. A list of the SQL functions supported by the UQE can be found in your help file. Also, if you'd like to take your SQL knowledge further, then a general Google search will provide some very useful results. A good place to start is w3schools.com. Before closing off, I'm going to go to my report manager and add the updated expressions back to my report. And what's important to note is that with the report selected, only the Properties, Columns, and Parameters tabs are shown. In the next lesson, I'm going to spend some time looking at how some of these tabs can be used depending on the type of container in question. Over the last 2 lessons, we've looked at 4 of the container types that can be used to define data sets in the connector, and I've pointed out that they are typically used in different situations to achieve specific goals or based on how you prefer to work. If you do choose to work with the more advanced types, the more you do so, the more their nuances will become clear. At the same time, I've provided some basic theory on SQL and given an introduction to SQL statements. The source definitions from my 2 data sets are also now in a state that I'm happy with. In the next lesson, I'm going to take a look at a number of other features provided in the connector and report manager to further customize the data in a container. This will lead into the 5th lesson and will put us in a position where I can finish off assembling my dashboard. I hope to see you there, where you'll gain an understanding of some more useful features provided in Sage Intelligence.